Okay, so here is the third part to 2.4, which is the factor theorem. So what the factor theorem says is, let f of x be a polynomial. If f of c is equal to 0, then x minus c is a factor of f of x. So basically what that's saying is that if there is some c that creates a remainder 0, then that means that x minus c is a factor. Alright, so basically that c is a 0. And then basically just saying vice versa. So if x minus c is a factor of f of x, then f of c is equal to 0. And so essentially what it's telling you is that any c that has a 0 as the remainder that c is a 0 of the function. Okay, so anytime you have a shelf or you have some c and you get a 0 as your remainder, that means that c is a 0 of the function. And what is a 0? Remember, a 0 is simply an x-intercept. Alright, an x-intercept. Alright, so that's all that means. So let's look at a problem. So we have a function Alright, and they tell us given 3 is a 0, find all zeros. Okay, so what's happening here is the factor theorem is providing us with a method to be able to identify the zeros of a polynomial function. Okay, so what we're doing is we are finding the zeros of a polynomial function. Now, this is what we've done already in 2.3. We were factoring given functions and we were identifying their zeros. What's different here is that all polynomial functions are not factorable. And so how are we supposed to be able to identify a 0 from a polynomial function if I can't factor it? And what if it's not a quadratic? Because yes, we can always use the quadratic formula, but like the example we have here, f of x is equal to 2x cubed minus 3x squared minus 11x plus 6. It's not factorable. I could try to split this and factor it by grouping, but it would not work. And so this is an exponent 3, which means we would not be able to solve it by the quadratic formula, because quadratic formula must have exponent of 2 as its degree. And so finding zeros with polynomial functions becomes something more advanced than what we've already learned. And so this factor theorem is what is going to allow us to be able to do it when there's functions that are not factorable, right? Not just quadratics. So here, this problem is not factorable, so what are we supposed to do? Well, they help us out and they tell us that they want us to find the zeros and they give us 1 0. So they're giving us 3 is a 0. And so we're going to use the factor theorem to be able to see how this helps us, okay? So because I know that 3 is a 0, what we are going to do is we are going to divide this problem down. And so when you're looking for the zeros of the polynomial function, you are always going to use an initial 0. You're going to use an initial 0 in synthetic division. As your C or your shelf number, right? You got to know what I'm saying. All right, so use the initial 0 in synthetic division as your C or your shelf. So they're giving us an initial 0. All right, they're giving us an initial 0. So we make 3 our shelf. And so we're going to do synthetic division. So my top row, 2, -3, -11, 6. So 2 comes straight down. 2 times 3 is 6. -3 plus 6 is 3. 3 times 3 is 9. -11 plus 9. Now, here's where the rules just start to get into play and help us be able to see what's supposed to happen. Because they told me that 3 is a 0, I already know what should be my remainder for this problem, because the fact that Theorem told me that. If it's a 0, that means that you have a remainder that is a 0. So I know if 3 is supposed to be a 0, which they told me in this problem, I know this should come out as a 0 here. So here, where we are, -11 plus the 9 gave a -2. -2 times 3 is a -6. 6 plus -6 is 0. I know I did my problem correct. Okay? So when you know you're using your initial 0, you're doing your synthetic division, you know what should happen. Okay? You know what to expect. You are supposed to get a 0 as that remainder. And if you don't, then that's not a 0, or you made a mistake. Okay? All right. So now we have divided this down. So in 2.3, we are introduced, right, to dividing polynomials. And we know that when we do synthetic division and we divide the polynomial, the answer is always going to be 1 degree less than what it was in the initial polynomial. So this would come out as 2x squared plus 3x minus 2. So remember, we're trying to find all of the zeros. And so the initial function could not factor. So I couldn't do anything with it because it wasn't a quadratic for me to be able to use the quadratic formula. So by dividing by that 3, I'm able to get my polynomial down to a quadratic polynomial. Now, since it's in a quadratic form, now I can solve by the quadratic formula, or I can see if it factors. And so your second step is going to be get polynomial to a quadratic. Solve by factoring or the quadratic formula. Okay, so here I'm just going to do the quadratic formula here, or you could factor if you know how to factor it, right? So the quadratic formula, x equals -b over, no, that's vertex. X equals -b plus or minus square root of b squared minus 4ac all over 2a. All right. I'm going to pause this and do this because I have no room. All right. So hopefully you tried to do it too. So I'm looking at -3 plus or minus 5 over 4. So remember, we'd have to split those up. So -3 plus 5 over 4, -3 minus 5 over 4. You have to work this all the way through. Like, that's what we're doing. We're solving for x essentially right now. 1/2. And then -8 over 4 gives us -2. All right. So we have our zeros. So our zeros are 3, 1/2, and -2. And that's what we're doing. We are finding the zeros of polynomial functions, but everything's not factorable. And so this factor theorem is providing us with a method where we can identify the zeros of a polynomial function, get it down to a quadratic, and then be able to solve the rest of it from there. Okay? So I'm going to do another one. Okay. So here we are solving the polynomial equation given that 2 is a 0. So one thing is, it's important for us to understand that the instructions are going to be different depending on the setup of the problem. So if it says find the zeros or find the roots, that's when it's given to us in the f of x form. But if it says solve, that means they already have set the f of x equal to 0. So it's going to have to equal 0 there for you already. Okay? All right. So they're starting us off and they're giving us some information to help us out because this polynomial is not factorable. Okay, we would not be able to factor this to solve it. And so we can't use the quadratic formula unless we get it down to a quadratic form. So the way that we get it down to a quadratic form is we're going to divide out an initial 0. Okay, so that's what's happening. They're giving us an initial 0 so that we can get this polynomial function down to a quadratic form. So we're going to use the given 2 as our shelf. And then we're going to use our synthetic division process in order to identify the coefficients for the quadratic form. Now remember, since they're telling us 2 is a 0, what do I know? I know this should come out as 0. So let's work through. The initial 2 comes down here. 2 times 2 is 4. Negative 5 plus a 4 gives negative 1. Negative 1 times 2 is negative 2. 1 plus negative 2 is negative 1. Negative 1 times 2 is negative 2. All right, great. It worked. Okay, so then I'm looking at 2x squared minus 1x minus 1. Now, here's the beauty of this. You can factor this if you want to. You can try to see if you can factor it. But when you get it down, you'll know it's a quadratic because A, B, C, it works out perfectly, all right? And also, it was only a cube degree. I would only need to divide it down one time to get it to the quadratic, right? Because every time we divide, it drops 1 degree less than the original polynomial. And so here, we can do our ABC, or we can see if we can factor this. So 2x squared minus 2x plus 1x, yes. So we would get 2x plus 1 equals 0. X would be equal to negative 1/2. X minus 1 equals 0. X would equal 1. So let's do quadratic formula over here. X equals plus or minus negative 1 squared minus 4. Alright, so we want to write this out and we just substitute it in to our quadratic formula. So x equals negative b plus or minus b squared minus 4ac all over 2a. Okay, so let's simplify it. 1 plus or minus square root of 1 minus 8. So plus 8 over 4. 1 plus or minus square root of 9 over 4. We want to make sure we know how to simplify this. 1 plus or minus 3 over 4. So what happens? It splits. 1 plus 3 over 4. 1 minus 3 over 4. 4 over 4 equals 1. Negative 2 over 4 equals negative 1/2. Oh my gosh. Look at that. All right. So factoring, quadratic formula, either way, right? And that's because these are factorable once you get it to the quadratic. But 2.5, they won't be. All right. So let's try another one. Okay. So here we're solving the polynomial equation given that negative 3 over 2 is a 0. So we're looking at 12x cubed plus 16x squared minus 5x minus 3 is equal to 0. All right, so our shelf number is the negative 3 over 2, 12, 16, negative 5, negative 3. So we set up our synthetic division. And now we're going to work through. All right. So the 12 comes straight down. So you should have your calculator with you. Negative 3 over 2 times a 12. So remember your ABC button. So you want to go through and multiply that. All right. So if you do it by hand, it would look like this. 16 plus negative 18 is negative 2. So then this would give me positive 3. Negative 5 plus 3 is negative 2. Negative 2 times negative 3 over 2 is positive 3. 0. Alright, so don't be scared of fractions. Use your ABC button or just do it by hand. Alright, because if the fraction is the 0, it's going to be able to work out for you to be able to get the correct coefficients for the polynomial, because it's just a dividing out, right? And so, I mean, even if they were fractions, use your calculator, but you won't get any of those fractions. All right, so what does that leave us with? An A, a B, and a C. And so you finish that. Either factor it, see if you can solve by factoring, or do the quadratic formula. Okay, so you should have gotten 1/2 and negative 1/3 when you do your problem. So I didn't want to use the 12, so I saw there was a GCF here, so I factored it out. And then it can factor, but I did the quadratic formula, so I substituted in my A, my B, and my C. But even if you had used the 12, 2, and then 12, negative 2, negative 2, it still would have come out the same thing. 1/2, negative 1/3. You need to make sure you're simplifying as much as possible. And then the factoring, would have been that. And so we would have gotten 2x minus 1 equals 0, 3x plus 1 equals 0. So then you would have gotten your x equal to your 1/2 and x equal to your negative 1/3. Okay? So, and actually the word 0 here would actually be changed, and they would use the word root. So anytime you have values for your zeros that are rational, like fractional, they're going to use the word root. So that's why the words are interchangeable: 0, root, or solutions. But they're all asking you to do the same thing: find the next intercept, essentially. Okay? All right, that's 2.4.